Hello, I'm Chris Thance. I'm a KMP developer, and today we're going to be talking about why code reuse via inheritance is always a bad idea. Oh yeah, I heard from tech support. It's a long story. I just don't want to. I really don't want to get into it, but it involves cables and power supplies, and getting the wrong ones again. They did it again. Okay. Anyway, hopefully I have that straightened out soon. What we're going to get into is some history. Got to talk about a little bit of the history. What object-oriented programming was supposed to be by two grumpy old guys take on the subject of object-oriented programming. And it's going to be three because it's going to include my take. And it's Ole Madsen from Our House University. When I saw that, first thing I had to say.
Our house in the middle of our street.
It's probably different. It's a different one, probably. Okay, quit goofing off. It's time to get serious. We're talking about code bases.
How do I switch here like this? Well, object-oriented programming has been around for more than 50 years and is currently the dominating style of programming. And a lot of applications, as you all know, have been made with object-oriented programming. So it's clearly quite dominant, no doubt about it. Then recently, one of our colleagues referred us to a number of blog posts with these kind of headings, like object-oriented programming, the $1 trillion disaster, etc., etc. And we were quite surprised, quite shocked, what the hell is that? And he told us that we really had to comment on that. But as with all information on the web, when you start looking at it in detail,
I'm pretty sure they're talking about the COP stuff. If you don't know what I'm talking about with the COP stuff, the COP, class-oriented programming, I go through this in detail in my course. Well, not really course, it's just kind of like a walk through how programming got to be how it was today, called how to program from the ground up. I talk about the difference between COP programming and the BOOP style, which is what these guys are talking about, the original OOP, which we're going to talk about where it came from and why it has this weird flavor to it of like trying to simulate stuff.
A lot of flow stuff. It's not grounded in solid knowledge. There's a lot of mistakes and errors in it. So starting to argue at this kind of level seemed quite hopeless. But there's also more profound critique. Some people claim that object-oriented programming as being practiced is not really what was the intention of the founding fathers like Dahl and Nygaard and Alan Kay. And also, a lot of people start saying that the era of objects is that nobody is really using it anymore, nobody is using inheritance, etc., etc. But it's
right. So this is the COP style, which was designed for a specific use case at the time when they were trying to simulate stuff before they could really do it on another way. So they were using. So this is why they created Simula and all the derivatives. And then Alan Kay said, "Okay, that's a cool idea," but then he's got some other things that he was doing with it. And then he took that thing they were talking about objects. He was the one that talked about object-oriented, which really meant message-oriented programming, which I call BOOP, back to the original oriented object-oriented programming that Alan Kay was referring to. Not these guys. These guys never really talked about it and called it that because they were on the simulation tip. They're trying to go down that road, and Alan Kay was like, "Ooh, that's cool. We can do this other thing with it that scales."
It's very difficult actually to get your hands on the exact critique of what people is thinking about it. But of course, there's room for improvement. So an OOP is no silver bullet. So we decided that we'd use this provocation to start reflecting upon what we think could be better with objects. So it all started with Simula, which was a language for programming and modeling. And Simula was.
And by modeling, they're talking about modeling the real world, right? I mean, trying to simulate stuff in the real world with these computers. Now they have enough memory and enough processing power. They could probably they thought they could simulate the entire world. And I think DARPA actually took off with that program, and there's some information about that. But they're trying. This is the rudimentary stuff back in 1960s. Like, how can we use the computer to simulate all this stuff we're trying to think about in our heads, and we just can't keep it all straight, and we're getting it wrong?
Originally inspired by Horst's paper on record handling from the 60s. And if you read in that, you will see that he actually emphasized this thing that when you want to do something in a computer, you have to construct a model of that aspect of the real or conceptual world.
This is where the confusion and the extension of the word object starts to break down, because object has so many definitions in English. The original one on the tapes was like the program, the data were together. And now they have this thing where it's conceptually being a model of some real world object, which there is some overlap between the two, but they're not. They went in this different direction, and that's why we're super confused still. Keep going.
So focus on modeling here. Richard, I should say, you mentioned that you tried to take in good invited speakers outside the area of Uppsala, and I still.
Right, right. So I'm going to interrupt a lot. You should go listen to his whole thing, whole lecture. But there's some points I want to make here that he's not bringing up because he's coming from the European style of the Uppsala simulation crowd, and he's actually realized, oh, there are limitations to this, and there's this other thing that Alan Kay was talking about that may actually be more interesting.
Remember this guy who talked about the maps of imagination and about literature. And I think this was really great because it has nothing to do with programming. It was about maps and literature, but it has been a main inspiration for us regarding modeling.
Right. So the modeling thing is now we're trying to use take our human model and put it into the machine, and that's philosophy. That involves like what is what delineates where, like what is a thing, what is not a thing, what is a thing in the system, what is a thing that's moving. You have to have this philosophical, artistic almost viewpoint, and have about what you're going to include in the system and not include in the system. Do you include every single grade of glass, or do you say there's grass here, and you don't go down the detail of every single little blade of grass? You have to make those kind of decisions when you're making a simulation.
Our own background is that we for many years worked with especially Christian Nygaard to develop this language Beta. And Beta was also a language intended for modeling as well as programming. So we have been heavily influenced by this singular culture, which is sort of dominating our view of the world.
And this is where the COP stuff came straight out of it. And everybody tried to apply this, oh, you can simulate all kinds of stuff. It means you can simulate anything. It's like, no, that's not what they were saying, actually.
And the reason we think that modeling is and should be central to object-oriented programming and programming in general is...
I basically, the people looked at this and they said, can we just take this and take your simulation thing and model anything with it? And they're like, I guess, sort of. So we can do, so you're saying there's a chance?
view of the world. And the reason we think that modeling is and should be central to object-oriented programming and programming in general is that when you have an object-oriented program and you consider its a modeling perspective, you have aspects of your application domain is directly reflected in your program, and your program is thus easier to understand than if you don't consider that.
So what he's talking about is like when you're working in a financial domain, if you're working in the realm, the kingdom, the empire, the province, the idea space of this domain, that you're going to use the words of that domain. So if we're in a farming, we're not going to call it animal unit 4, animal unit 3. We're going to call it a cow, a dairy cow, a different type of cow. You know, we're going to use that language. We're not going to extract it out. And you're saying that is a big part of how we make the programs operate properly and everyone understand what's happening and nobody's getting super confused. Keep going.
And when all this stuff about object-oriented analysis design started in the 80s, Code and Yorton put it that way, that we actually based it on concepts we learned in kindergarten. That may be a kind of simplification, but there's something about it. If you look at mainstream object-oriented programming, we don't...
And when he says technical here, he means mechanical. They're just showing the mechanics of the language, and they're not really talking about how these things should be used or why, because that's another level of abstraction that they were never taught, because it's this level, because it was eschewed by the COP crowd as not important. And it's vitally important. And that's why we're into this mess right now.
Don't see any signs of modeling at all. Now, this is perhaps
right, they imply it here, but the examples they use, they don't really understand why they're using those examples. They just a lot of times they're just mimicking something they've always heard, like the whole animal thing. God damn, that we never use an animal in programming. That's why, like in my examples, I try and use like actual things we use when we're actually making these things, like a file. A file could be like an abstract concept, and you have a text file, and you have a binary file, and you have an Excel document of those types. Blah 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 blah.
This is perhaps I miss the English words, but we don't see signs of modeling in mainstream, and this is really very bad. And if you look at textbooks,
right, because it was eschewed and it was canceled at some point, and people said, "Okay, we can't talk about that now. That's not programming. We have to do this other thing where we're just dealing with data, like the procedural side." Because this type of thinking made the procedural people very uncomfortable, because they didn't get to use the maximum amount of their machine, of their petty little, pathetic little weak machines. They didn't understand that the machine was no longer going to be the bottleneck. It's going to be communicating these ideas over time and making them changeable and modifiable, not getting every last ounce of the performance out of the machine at all levels of the stack. No, that was so we're getting out of that thinking. Thank God. The big guys are figuring it out. Like, you can't do it that way. We have to abstract out. And the C++ reign is probably going to be over soon. So this other thing is going to have to come up because all these little companies are going to eat their lunch, and that's why what's happening. And that's why they're going to have to be forced to change because it'll happen, without them. And they're going to have to let go of their management style of everything top down. It's like, no, you don't get to do that anymore. If you want to win.
On object-oriented programming, they hardly mention modeling. There is this book by Barnes and Quilling where they mention that you construct the model, and that's sort of all about it. And when I say mainstream, it's about how practice is applied using languages like C++, Java, C#, Python, but also Smalltalk and other languages. And
right. They still have that COP style because they didn't understand what Alan was talking about. Because Alan, I mean, he did his best, but he should have changed the name. Why didn't you change the name, Alan? You could have just changed the name back then. You said, okay, you got the object-oriented thing. You got that one, guy. Go for it, C++, guys, AT&T. But that's not what I'm talking about. Why didn't you just change the name? You could have changed the name.
In the Smalltalk book, you see no mentioning of modeling at all there. And the same with most research papers on object-oriented programming. It's very technical. It's about type theory. It's very, very little about modeling.
And that's the stuff that's easy. So that's why they put it in there, right?
So our main message in the paper is that there has been too much focus on code reuse in object.
Exactly. This stuff here. This totally derailed it. And the C++ guys are super into it because you can get away with it for a little while. But in general, no, you cannot unless you design it that way. And if you design it that way, you're going to go the poop style, which is you can't get the maximum performance out of your machine. So there's trade-offs.
Too little focus on modeling. So our recommendation is that one starts reintroducing modeling as the main benefit of object-oriented programming.
Yeah, the poop style. Yeah, it's the modeling is the most important thing. We're gonna figure it out. The Alan Kay was right. The boop style is important. Yes, and the boop style is the way to go. But everything underneath it is implementation details. If there's a bottleneck somewhere and you got to use a C++ or C or some low level language, yeah, okay. But in general, no, not through the whole stack. Why are you doing that?
And this is sort of what we will go through here. And clearly, if you look at mainstream, reuse is considered the main advantage of object-oriented programming.
That's the first thing they hear. Oh, you get to reuse code. Oh, do I get to reuse it? Can I take the work I've already done and reuse it? Stop.
By most authors. And of course, object-oriented languages provided new mechanisms for reuse, class, subclass, inheritance, virtues, etc. But the downside is that modeling was sort of fading away.
This was a thing that people said. I was like, what are you talking about? How do you not know what you were doing with your program? We don't do that anymore. It's just data. Even though it's object-oriented, we're just moving data around.
And we often hear that
it's different.
Real programmers do not model. And this thing about inheritance as a reuse thing.
Yeah, this is where this stuff came from. Inheritance is incredible. No, it's not. It's bad. I want to see the code base of Wegner and Zognick now. Did you still go with that? Is it still increasingly changing and becoming more different thing, and you're still maintaining it? Oh, let's see. No? Never heard of it? Oh. All right. Okay. Yeah, objects model the rails never appealed to me. Yeah, completely missing the point. This is another procedural guy. Peak objects. This is another procedural dude here saying, I just want to swish the data around. I don't really care if you understand it or if anybody else has to maintain it. I just want to swish the data around as fast as possible. Does your thing perform it? Because I got to make 5% more performance because the guy down the street's got 7. And I'm at 2, so I need to make 5 to keep up with him because he's performing. Yeah, okay. The ultimate goal of object-oriented programming should be code reuse. No. See, this is where this stuff came from. Bono and et al. No, you're wrong, procedural boys. No. I mean, you have your case, but you're not going to do the full-blown revolution of the computer revolution that Alan Kay is talking about with this type of thing. Oh, it's a code reuse. It's a code reuse. No. Inheritance at times is a useful feature, and I believe some code reuse. Like inheritance is a very important part of management. Okay, whatever. No, what are you talking about, dude? Andrew Black, what are you talking about, man?
It's back to a very influential paper by Wegner and Zognick called inheritance as an incremental modification technique.
No, I want to know where your code base is after 10 years of this. Let's see how well it's held up as you reusing everything. See if anybody can maintain it without 9,000 rules. Don't touch this. There be dragons here.
And I should say that these people here, which we may disagree with, they are all or have all been good friends that we have enjoyed working with for many years, but we really disagree with them. Wegner was a long-term friend, and we learned this morning that we lost William Cook last year. And but he and I has had lots of discussions on modeling, etc., etc. But this quote here is from the paper he wrote at a special anniversary sequence session at ECOP. And then Andrew Black recently wrote for the similar anniversary that he thinks that code reuse like inheritance is very, very important. Now, Andrew Black is my favorite person to argue with. We seem to disagree about almost everything.
Because he's talking about something different. He is super concerned with performance. He needs to eke out every last little cycle in the machine and doesn't care how long it takes to fix it or what it takes to maintain it. He don't care about that. He's doing this other thing. So you're never going to get aligned on the same page because this guy has got his thing he wants to do. He's going to push it through. And God, whoever comes after him, good luck.
So hopefully some of you will take his point of view here today. But there's no yes or no or black or white here. It's all a matter of your perspective on things.
Right.
What we have been trying
What is important? What a trade-off are you looking to do to take off? These machines are super fast. They are still growing in speed every year. Why are we talking about these tiny little cycles? We're about to 2 months or 5 months from now, it won't even matter. You're 2%. That's 2%.
to do is identify what we consider a number of problematic issues of mainstream object-oriented programming. And as I said, it's a subjective analysis, so no yes or no here. So the main message is that by focusing solely on reuse, the benefit of modeling is lost.
Correct, because you're doing the performance stuff, you're grabbing stuff, you're accessing private variables, you're everything's talking everything else. It's super efficient, but don't you dare touch it.
Or has been lost. One problem with mainstream is this notion of implementation inheritance, where people take a class, they make a subclass, they redefine whatever they think needs to be redefined, and then they have some new code. So a lazy way of reusing stuff and redefining what you don't really need. And one standard example is this definition of a class stack that simply inherits from a class vector, because then you have most of the functionality you need, and it's very simple to make the stack. But the problem here is that there's no conceptual relation between a stack and a vector. A stack is not a specialization of a vector. When you use subclasses, you should be sure that your subclasses are all specializations of their superclasses. If you don't do that, your subclasses are all
So the point here is like, this is there's like no conceptual relation. It's just using this as an array because it knows that this guy that did the stack thing knew that a vector is an array and you can use it for that. But so this is more like this. This is subclassing. This we call the subclassing because you just take one class and just jam it onto another one or around another one. And this is more of the subtyping where you're each layer is becoming more and more specific, more and more specific, more and more specific. This is just saying, I'm just taking your stuff and I might use it your way you want it to be intended. I might use it in a different way. What are you going to do about it? Nothing until you change it. Of course, I'm going to have to go change all my code base to reflect the new change and reflect the new change, or reflect the new change, or reflect the new change.
Visualizations of the
Get into it. See, I got this example here. We're going to get into it. I've taken the time to make this extremely pedantic about why this is a bad idea. And we're going to get into it because this seems to be a major issue and a major point of contention with a lot of developers. And you have to decide, are we trying to maintain this code base or are we just trying to get it done today and get it out as fast as possible? Because yes, both constraints are there. What are we doing? Let's be clear about it.
If you don't do that, you will have a hierarchy of classes with no conceptual relations other than a reuse relation. You have class hierarchies that may be difficult to maintain and navigate. And worst of all is that if you may have a subclass which is not sort of compatible with its superclass. So one of the nice things about object-oriented programming is that an instance
we'll get into how that's possible. It's like, what do you mean? What are you talking about? What are you talking about there?
of a superclass should be able to be used at any point of its superclasses. But this may all be destroyed if you use solely implementation inheritance. And as I said, the benefit of modeling is that the program reflects the domain.
So he just flipped. He's flipped now. He's talking about how doing modeling is really the way to go because it's going to help us all maintain this beast and maybe work more efficiently and easier.
The program is a description of a model of the relevant aspects of the domain. And such descriptions are good for communication, also among others than programmers. And it's much easier to understand a program if it's really reflecting your application domain.
Exactly. Right? I mean, we can't keep saying that over and over again. It's like, look, the application on the inside has got to look about how we are thinking about it on the outside, because that is the model. And there should be no transfer mapping layer thing. It's just trying to make it as direct as possible to make everybody's lives easier.
Another issue is this business about virtual and non-virtual methods. In Simula, you distinguish.
Yeah, this is the whole thing about, okay, and so in Kotlin and in Java they call them Kotlin, they call them open classes where you're allowed to derive from them. So in C++ you have this way of like saying, oh no, you can't take these, but you can take these and change them. So they have, that's what's called the virtual. What's virtual? It's virtual. It's different. It just means that you can derive from it. No, it doesn't mean just it just means you can override it. Is that all it means? No, it's virtual. Stop, you guys. Quit it.
With virtual and non-virtual methods. And just to make it short, in Smalltalk and Java, all methods are.
Yeah, this just means you can't drive. So he's just getting some technical syntactical details of certain languages, what it was letting you do, what was not letting you do. There we go.
Virtual.
So you couldn't say not do this in Smalltalk. So that was the thing. It was like they didn't really think like, hey, maybe we should make it so we can show the intention. You're not supposed to override me. You're supposed to do something else. No, laughed it out. Whoops.
And from a reuse point of view, this provides maximum flexibility, of course. But the problem is that it's not possible to express that some behavior of a class is the same for all subclasses.
Right. This is it right here. It starts to get, when you start doing this implementation, it's real easy. Somewhere down the chain, someone's using it, and then up the chain later on, something changes, and then it messes everything up. It totally doesn't work the way you thought it was going to work. And figuring out what went wrong becomes a real problem. Oh, yeah, let's go just start debugging. Yeah, let's start debugging just because the library changed. Okay.
And for a user, it's not at all obvious which methods that needs to be redefined in a subclass. You may use these keywords final and sealed in Java and C# to fix some of this, but in general, when virtuals are default, most methods are in practice virtual. And virtual procedures in Algol were introduced as a replacement.
I would just like for our house university to please in the future, could you not just do a white screen? This is really super hard to watch.
For name parameters and formal parameters.
Dark mode. Embrace the dark mode for our eyes, please. Getting blasted with the blue rays on this thing.
And if all methods are virtual, they are in fact all potential parameters. I did mention this paper by Wegner and Sedonic on incremental modification. And Black, Bruce, and this gentleman sitting down there actually considered inheritance as a mechanism for starting with a concrete bait and later abstracting over concrete elements and sort of be able to redefine everything. And they call this ex post facto parameterization.
Such a bad idea. I wonder where their code bases are. Hey, Wegner and Zodnik, could you let us know about your code bases that have implemented this incremental modification mechanism and what it looks like today and how easy it is for everyone to work in, what your employee retention looks like, what your dev retention looks like, and how much it actually costs to someone to come in and actually deal with this stuff? Could you let me know? Oh, no, you're silent? You're quiet. Okay, gotcha.
Sure, I can be corrected if I'm wrong here. But I think the problem with this way to go is that the interface to a superclass is not well specified.
Right. You don't know. You're not actually saying how it's supposed to be used. It's all tacit knowledge for everyone on that team at that particular time. Somebody looks at the code and like, oh, I can just extend this. They're like, you should never do that. Rule number 846 says you should never do that.
And it's not clear at all which kind of methods to redefine in a subclass. And also I think there's some Mac PC problem here, that when you redefine
complaining about this, he's like, God damn it.
A virtual message.
Damn machines. All right, shut up. Shh, quit goofing off back there.
PC problem here, that when you redefine a virtual method, you really need to make sure that the redefinition extends the definition of the one in the superclass. Because you have to make sure that, oh, sorry, that was too quickly.
Yeah, okay. We're going to get into this. Why? We're going to talk about almost similar related problem, but it's not super obvious. Like, well, okay, this sounds fine. He's not explaining it super well. The syntax is all C++. It's like, ugh. But I'm going to explain. I'm going to show you here. You can download and play with it and see for yourself why it's so crazy.
That all possible class invariants, pre and post conditions of the methods being redefined also fulfilled in the subclass. So just don't redefine stuff. Now, I mentioned that the
Oh, by the way, if you want to download now and just start messing with it, the links in the doodly do.
some people say that OO as practice is not what Alan Kay had in mind. And there is an interview out there where he said that object-oriented programming is a set of objects sending messages to another, and this stuff about subclasses, etc., was just something somebody at Park Place added without he really knowing. So, but we don't think there's any conflict here, and would like to mention that for Simula, it was essential to be able to model processes as well as objects with data and methods.
Right. So this is the inheritance, where it came from, and in my course I go into talking about where this stuff came from and why. And this is why we have this weird flavoring coming through. We have these two camps fighting it out in the ecosystem, and one is kind of like overpowering the other one because a little bit more resources, AT&T, C++.
So still, if you look at Simula, a class may have a statement part, and it actually behave like a coroutine, and it may behave like a concurrent process. So objects are in Simula actually active. And no one of the mainstream object-oriented languages has taken this over. Smalltalk objects are not active objects because they are just receiving messages.
Right. So he was talking about like the procedural style. They kind of like they mishmash this together, right? And Alan Kay is talking about the message-oriented style. What I'm calling BOOP, back to original, back to oriented object-oriented programming, back to object-oriented programming. I call it BOOP.
But singular objects are active. So I think this is one of the things that mainstream languages could still learn from Singular, even if it's many, many years ago. One of our main messages is that we consider programming as modeling.
Right. So, and what I've discovered is a lot of people in programming, some people did play with Legos and other ones didn't. And I think there's a big reason why people don't understand why modeling is super important, and then they've never built a model, a physical model, like a real model. It's model something else, art, whatever, something tries to look like something else, and has to kind of perform and do something, not just blobs on the page, but like actually do something or support something. Legos tells you a lot about like how much you can support, how much weight you can support. Like there's a lot of stuff that's built into tacit knowledge you pick up by like you can't extend things forever. If you haven't architected it properly, it's gonna fall over. And some people just haven't experienced that with their own hands. And
I hear very little also so far at this conference about programming as modeling. So our claim is that it's necessary that programmers must learn to model. And this should be taught as an integrated discipline together with programming.
Yeah. There has to be a separate track. There has to be a separate track. There has to be this like computer engineering crowd. There has to be the absolute performance mavens. Like, it has to get the bleeding edge of just the maximum cycles. Okay, that's one thing. We need that. We do need that. But in general, most application developers are not going to be doing that stuff. Kind of need to know how it works at some level. But in general, we want to be abstracted up. So we're talking about this other thing where we're trying to apply these techniques to the real world, and we have to find a way to model. And I was never taught any of this stuff. I've never heard of any of these. I think the boot camps I went to, none of this was ever discussed. I'm talking about it the whole time. It's like, what model? What's your model of here that you're coming from? Like, what do you think? What is your idea here? What are your metaphors? And my first reaction is like, are you extending the metaphor too far? Are you aware of the other meanings of these words? It's all like humanities, liberal arts stuff, and the computer people hate it. They hate it. It's all humanities and like how people relate to each other, and it's all this stuff. How people can work together, so we can work together most efficiently and have a society. Okay.
And as I mentioned, this is not the case with most teaching and books on object-oriented programming. For the beta language, we actually developed what we call a conceptual framework for organizing and understanding knowledge about application domains. And this sort of includes
this is too computery, but I get where they're coming from. I appreciate the effort.
Definition of what is really an object-oriented model. Something about how do we understand phenomena and concepts from the application domain.
So this is liberal arts. Sorry, this is liberal arts. You can't just introduce this in a one semester course. This is like reading and like going out and like going other areas of the world, like discovering how other people live. working in businesses you hate, working in businesses you love, trying different things, being in the world, experiencing things. That's where this is. You can't just, well, we're just having one semester. Here's modeling.
Something about teaching people about conceptual means such like classification, composition,
Phenomena. This is philosophy. This is abstract mathematics. This is read the collected works of Homer.
context, association.
The Iliad. Catcher in the Rye. No, never heard of it. 1984. No. Brave New World. How about Brave New World? Let's go through Brave New World and look at it.
Starting with a model, there is some disagreement about what is really an object-oriented model, but in our interpretation, it's the program execution that is the model. So if you have an application domain,
I would have not used dashed lines here. I would have just used a straight line because, whoa, can you see like what is hooked up to what? And why does this at a different angle here and it's broken here? Does that mean anything? This is broken here. Guys, get your graphics guys to work on looking at some. Does this connect to this? Are these connected together? This chart's a mess.
Here with a lot of vehicles, cars, buses, and trucks. Then the model is the program execution with the objects.
And the audio, come on.
Cars, buses, and trucks. And the program is a description of the model. The program is not the model.
Right. The program is a description, a representation of the model. Right? So we have to have the model, this conceptual model, and then the code is representation of that model. It's one removed. If we could put the model into the computer somehow and just have that thing pre-exist in its own space, we'd do that. If we could actually put little cars down there, and all the little pieces, everything put down there, we can put that down there, bip, and have it exactly be the right thing, we would do that. But we can't, so we have to do the abstractions. And that's how it comes through this language, right? This is the abstract language of this that represents this, right? This is all the data structures laid out in memory, having their values all changed that represent these little things down here. Okay, right? This is the modeling. And some people don't say you can't do this, don't do it, skip it, it's stupid.
The description could also be a UML diagram.
He really said
the
that.
The UML community consider the diagram to be the model. If you look at...
Sometimes I think some of these things, these ideas have been percolated through, were inserted on purpose to make other businesses way more competitive that are using this stuff internally and aren't telling anybody. And they're just like, nah, that stuff's stupid. We're doing this other thing.
A Lego toy for building a model of this mini. Then you will consider the Lego model, the Lego car, the model, and not the instruction set for constructing the model. The instruction set is like the program. It's a description, a prescription of how to actually build the model. And we think this is very important to be aware of, that it's sort of the dynamic stuff in the computer.
Great. Let me get myself out of the way.
That is really the model. So my car here may be a representation of the mini, and I may have a UML diagram or a programming language description of the model, actually. I mentioned that people should have some common understanding of what kind of phenomena do they actually meet in an application domain. If you look at these vehicles here, you can see each single car is what we call a physical phenomena. It's actually some substance, some material. And the weight and license number of a car are properties of these physical phenomena. And the car trip from home to work is an example of another kind of phenomenon, namely, which is a transformation that changes the states, the properties of the cars. This is a very, very, very short way of presenting this stuff, but it's kind of the thing that we think programmers need to know about. Similarly, for concepts, people should have some idea about what is a concept and be aware of examples of domain concepts when they build their models or programs or whatever. Then I mentioned this thing about conceptual means for understanding and organizing knowledge. Classification, which is about organizing phenomena and concepts in hierarchies. Composition, understanding the structure of physical objects as part of wholes. Context, understanding the context of phenomena and concepts. And associations, which are sort of relations between phenomena.
Show me the code, dang it. Enough blibber blabber about the modeling. Show me the code. This is the work. This is the work that AI is going to have a real hard time dealing with, and it's going to need a lot of help from humans because it don't understand what the hell we want. You know what? And as soon as it does, your job's done. your job's over with. But like, and we're kind of. I hope we get to a society that like the computer takes over and everything's great. But we've been warned several times about this in the sci. Have you watched the sci-fi movies? No, no, never heard of Terminator. No, never. Okay.
If you learn about classical concepts, you will learn that a concept is characterized by an extension, which is the phenomena that are
I believe this is philosophy we're getting into now. So where's the coding? Where's the computer engineering? Where's the performance?
covered by the concept. And here for a vehicle, we have that the extension of the concept of vehicle are all vehicles. The intention of a concept is the properties of the phenomena covered by the concept.
I think he meant intention, but we'll keep going.
And concepts may be organized in these generalization, specialization hierarchies. And if you look at the extension of a specialized concept like the bus, then this is a subset of the extension of the generalized concept. But the intention of the specialized concept sort of extends the intention of the corresponding generalized concept by adding additional properties. This may explain why people sometimes talk about subclasses, because this goes for the extension. And in Java, you say extend, this sort of goes for extending the intention.
So there's all these metaphors being mixed up, and it's no wonder everyone's confused, right? It takes quite a bit of effort to separate these two things out and wonder why and why it's important. It's like a couple levels deep, and most people don't want to get that far, right? They just have their C++ thing, they've been told to use it, and now they got to get the thing performance, and even though they're just calling API calls. Okay.
And of course, classes may represent concepts, subclasses may represent specializations, and they should represent specializations, and class hierarchies may represent classification hierarchies, etc. And the essence here is that properties specified in a class are inherited, sort of imposed on subclasses. I have no idea about time here.
We've got 20 minutes left, but we'd like to leave some time for questions.
Good, good. A final issue.
Oh, God. I didn't realize that. So multiple inheritance, I know it was already bad, and it was banned in Java and available in C++ and caused all kinds of problems. I didn't realize until I saw this slide that the mixins and traits were all the same thing. And trait mixins in JavaScript, it's kind of how you do things, kind of how you add functionality, but you can go crazy with it and lose your mind, right? And it's really hard to track what it is. It's all happening in runtime. Which is the positive, right? That's the benefit, but also the downside is you have to deal with the complexity, so don't go crazy with it. Oh my God, I got the mix-ins everywhere. And then the traits, I'm not sure what traits are. I think it's coming from Go or Rust or something. But if it's the idea of multiple inheritance, ooh. No,
about
bad idea.
Multiple inheritance and classification. It may not be that big deal anymore to discuss multiple inheritance, but it's really something which is very...
But at the time when they promoted this, they said this was going to solve all your problems. And all it did was made things about 100 times worse. And it was deprecated, but it went on for a while. People are like, well, have you heard about the multiple inheritance? I talk about it in my course. It's like, this is ridiculous. Are you guys really, this is what you guys are talking about? No wonder it was banned.
Complicated. And here we recommend that people learn about properties of classification hierarchies, because we know about these tree-structured classification hierarchies. We also know about non-tree structured classification hierarchies, which is what a multiple inheritance often give you. But also there is a situation where you have several independent classification hierarchies.
And people don't understand which one is which. They all look the same. They all have the same keywords. They all look like they're doing the same thing. We'll just add on to that one. Oh, but you can't do it on that one. You have to add on to the other one.
And also you may have classifications where objects change class membership over time. And finally, you should also consider classification of actions. In beta, we actually are able to express that a method may inherit from another method, so you can have hierarchies of methods and processes.
That kind of makes sense.
And as an example of an independent classification hierarchies, you may think of something like this, where you can want to classify people according to their profession or according to their nationality, which are two sort of independent classifications.
These are two domains. The domain of who company are you? What country are you from? The domain of what kind of work do you do? Those are separate orthogonal domains. They don't relate to each other. So if you try and combine them together as one unified thing, okay.
Hierarchies. But if you use multiple inheritance just under your arm, you may end up with subclasses like an European teacher or an Oceanian nurse or whatever, lots of combinations. I know that there are no real languages that support this kind of classification, but at least it's good to teach it that there are these kind of classification hierarchies, and students or
Well, this would just be two separate ones. What are you talking about? Just be two separate ones. Okay, what's the matter with that?
programmers should be aware when they sort of meet the limitations of their programming language.
Because in this domain, when you're trying to go across the U.S. border, or you're going across a country border, they don't care about this. They don't give a crap. It's kind of tangentially, maybe. But when you're going for a job interview, yeah, they're going to really be zeroing in on this. It's not so much. Maybe in other countries, but in America, they're like, no. If you got, do you know C++? Can you solve our mutual shared state problem without changing the code base?
Now, I said modeling is not really present in object-oriented programming, and people may ask about the modeling community. It was actually quite good when people like Colin Jordan, Rombach, Booch, and others started presenting ideas about object-oriented modeling in the 80s.
Okay, I'm gonna let you watch the rest of it because that's really good, and I've used these his techniques about having graphs that show that they are visual, and you change the code and it changes the visual. And he's going to a thing where you can actually go to the visual and edit that, and it'll change the code. That doesn't exist right now, so at least one way. At least you don't have to draw out the damn thing. You can write the code for the diagrams, and I use it all in my course and talk about it a little bit. And that's what he goes into a little bit there. So let's go ahead and no more of that. It's a one-time. That's a one-time pony on that one. Okay, so we're gonna listen to this professor talk about this thing here about interface versus implementation inheritance. So there's interface inheritance, which does make sense because you're just saying, I'm going to be able, you have to have this stuff defined to be a member of this type. That's one thing. That's fine. But this implementation inheritance, when you're doing class, that inherits from a class, like this verbose dog takes from dog. This is an example he's going to use. So he has it in Java. He doesn't run it, which, come on, guy. And here we go.
To wrap up this lecture, let's compare and contrast the types of inheritance we've seen in this lecture. So the first is interface inheritance. Love it. It's wonderful. It's just a great idea. It tells you what you can expect from your subclasses. So the superclass or the interface says all lists must do these things and allows you to generalize your code in just a powerful, simple way. So if we look at word utils, for example, this longest method, it works on any list and not just
word utils. So it's a static. This is OP. Keep going, Chris. Stop retching. Stop.
Any list that will ever be written. So if in 1,000 years someone digs up my code, like my skeleton laying somewhere holding a USB drive, and they find this, and they're like, yes, this is good. And they're like, well, we don't have a list implementation except this weird 1Q list. Well, as long as it obeys the list61b interface, I don't know how it would. It'll still work. That's nice.
So you're just talking about how interfaces work. All right, that's fine. I'll allow it.
There's also this other kind of implementation inheritance, which tells you how the subclasses should behave. Okay? In this case, the boss is telling its subordinates exactly how to do their job. So this is nice because the boss can provide a general working print method, for example, that anybody else can use. So if you make a new list called QList and you're not quite sure how to print, you at least have that laying around. It may not be the most efficient way, but it's there. So it gives you an extra level of control. You can decide to override it, not override it, so that can be nice. Now in both cases, I want to point out a common pitfall that you may fall prey to. Anytime you use inheritance, either kind, you should be specifying an is a relationship and not a has a relationship. Okay? What do I mean by that? Well, an example of an is a relationship is this. A dog is an animal, right? I mean, every dog is an animal. And likewise, every S list is a list61b, right?
Okay, his lanes are horrible, but okay, we'll get into it. We'll let him cook. Okay, let him speak. But just
by contrast, if you read it as has a, that's no good. You don't want to use inheritance in that case. So for example, if I make a class called cat and it implements claw, it is true that cats have claws, but a cat is not a claw. Now you might say that seems weird. Like why would I ever even try to do that? But here I think is a better example where you can maybe see why you might get tempted into going to the dark side. So if I say set,
at least he's true about that.
implements slist. Basically what I'm trying to do is implement a set using an slist. So what's a set? A set is a collection of objects that can have no duplicates. So for example, if I call add first potato, add first potato, add first potato, there would be only one potato in the set.
This is why I include this guy's video because he's a little bit pedantic. Because when he said he just added potato 3 times, I appreciate that.
You can imagine trying to override the slist methods to capture that behavior, whatever it may be. And so in effect, we'd be contorting an slist into a set, but it won't work the way you want. It's going to end up being much more complicated. Okay? So that temptation.
Not at first. Not the day you do that. When you put that in there, it's going to be fine. It's going to be fine. And what's up with these CS people with the light screen? Come on, dark mode, please. We're human over here.
To use interface or implementation inheritance to capture has-a relationships, please avoid it. Okay? So that aside, I actually want to talk just for a moment more about some of the reasons I'm a little skeptical of implementation inheritance, why it can cause you trouble.
Skeptical should never be done. If you're doing it, ask yourself, why are we doing it this way? What is the model that we're trying to put together here? And did you know? And do you know what happens when you get these things extended too long, a couple years from now, when we still have to support this code base that we just added this deadly decision? Keep going, Chris.
So one issue that sometimes applies is it can make it hard to keep track of where something was actually implemented. So imagine you have a deep stack of like 6 or 7 implementations. So, you know, I have animal, and then I have like carnivore, and then mammal and dog or whatever. It can be hard to potentially keep track of where things got overridden, where they got defined, and so forth. Though a good IDE makes
Hard to? Chuck, okay, this guy obviously maybe hasn't worked in the industry that long, or hasn't worked on it for very much, or in different code bases. It's a nightmare. It is a completely unmaintainable nightmare. You have to tack on 20 IQ points somehow, and usually these guys are popping speed pills just to deal with this crazy stuff. No wonder the code's so, you have to be on it for 140, 160 IQ just to read what the hell's going on.
that pretty much okay, but it can mean some extra complexity.
Yeah.
Well, sometimes you can get strange conflicts. So imagine you have like service and like service or helper, we'll say. So you have a helper interface and an animal interface, and then you want to make like a service dog class that implements something from, or implements both of those superclasses, those interfaces. In that case, if there's a conflict between these, maybe they both have the same default method. There's some complicated rules about resolving those. Not such a super big deal in Java usually, but it's one thing that's a little ugly about implementation inheritance in general.
It doesn't go into the details about why that's a problem, but if you had one dog was a bark and the other service dog is also bark, which one's it going to call? That's that multiple inheritance stuff. That's just silly. Why are you guys doing that? That's modeling the wrong way. Back, rewind, go back to philosophy, guys.
Another one, and this is where it's starting to get worse, is it encourages overly complex code. Because when you have a hammer, right, everything looks like a nail. So whenever you know about inheritance, especially when you're new to it, you're going to want to go nuts with it, possibly. And the biggest mistake...
Oh, and especially when it's promoted by all the people, all the academics saying, it's a pretty good idea. We'll just build it up a little piece at a time. It should be fine. 2 years from later, we can't make any changes, and we have all these rules. Did you mention all the rules? Remember 249 says you can't touch that.
Mistake people make is this has a versus is a problem. I actually had a similar thing at my first internship a long time ago, where I just learned about Yak, I think it was, or Lex, or one of those compiler writing tools. You've never used them probably, but I had
I have, whatever.
task, and I managed to find a way to use, I forget, it was like for generating random parameters.
Yak means yet another C compiler. Thanks for not letting us know thanks for not letting us know the acronym, Professor.
For some program. And it's so funny, like I think back at this piece of code and how I managed to use the tool I had just learned about in an overly Byzantine way to solve a problem. Inheritance, especially implementation.
And these types of guys, Malvin, he likes to use all the features he just learned about because that's a programmer, right?
Inheritance.
Okay, I give him a break. At least he's letting you know it's a bad idea. Okay.
Use the tool I had just learned about in an overly Byzantine way to solve a problem. Inheritance, especially...
Yeah, we have to support your code, dude. And you've moved on. You're like, this company sucks. The code base is terrible. I can't work with it. And then somebody comes in and goes, oh, I have to deal with this guy's code now.
Implementation inheritance, and only implementation inheritance, I'd say, leads to this just gross behavior. But perhaps worst of all...
At least he admits his error of his ways. Thank you, sir. Thank you.
Is this fact. The fact that it breaks encapsulation. So I'm not going to tell you exactly what that is. We'll cover it in a couple lectures. But just for now, understand there's some philosophical exceptions I have to implementation inheritance. Now, I'm not saying it's bad. I mean, it's a wonderful tool. There are cases where it saves you tremendous amounts of time and it can be very lovely. But
yeah, when you're just trying something quick and dirty and there's something going on there. Don't plan on keeping going with it.
Like interface inheritance, which for me is a clear win, implementation inheritance could be a little bit shaky. All right.
A little bit? No, it's a really bad idea. Let's get into it. So this is him a little bit like a couple years later, I guess. And his slides are improved. Now it's like it's mauve instead of white. Okay, shh, shut up. Just listen to the professor.
Let's see now how implementation inheritance breaks encapsulation. Suppose we have a dog class that has these two methods here.
I'm doing this right.
So there's a bark method that does system.out.println bark, and bark many, which uses a for loop to call bark many times. Okay. Now, to a user on the outside, I can say bark many 5 times, and I should get bark, 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 bark. And I don't really care how it's implemented. I mean, this is one possible implementation, but I have a certain behavior in mind. Now, it's possible that later, let's say the Oracle company is maintaining the dog class. Maybe they decide, someone comes into work and says, let's switch these, right? So what I'm going to do is make the bark many method call printline bark, and the bark method is going to call bark many 1. This will work exactly the same, and this change, from an outsider's perspective, there is no difference, right? I can call both of them, I'll never see a difference.
Okay, so let's go through his thing. So, dog.bark. All right, so let's comment this one out here, and we'll just see how this runs. Let's do that. Let's just see how this runs. Where go? I'll pause it. All right, so it just prints out woof. All right, okay, and he's saying that they've changed it now to something else. Let's see what's going on there. He says bark many. So let's see here. All right, so we're getting rid of this one. All right, and we're at it, and we're gonna get rid of this one and add the new one. So we're getting rid of the old one, and we're adding the new one. There it goes. And let's see what happens there. Okay, looks like we're getting some sort of weird looping thing going on. What's going on there? What's going on there?
So here's where inheritance causes trouble. Even though I may not even have the source code to dog, even though it's built into Java, I can write my own dog class. So maybe I write one called verbose dog.
So we got a Stack Overflow, so it's calling around doing a loop. All right, do you see anything where it indicates there's a loop going on here? A recursive loop? No? Just by calling the same bark and just because you imported a new library with a new improved dog, but completely unaware of how somebody else is using it? Here we go.
And what is verbose dog? Well, it's a method that starts off the bark many method by saying, as a dog I say, and then calls the bark method multiple times. So let's imagine, here's my hierarchy. I have a dog class, it has a bark and a bark many class. Verbose dog only overrides bark many, so it inherits bark from above. So the question is, if I do vd.barkmany3, where vd is a verbose dog variable, the question for you is, what does this do? So ponder that for a moment. What will it actually output? Okay, so we have to turn.
So let's go. So that was that bark many. That was just that bark, which it does this weird loop thing. Hold on here. All right. So yeah. So what's going on is it's verbose dog is overriding the bark many. So when this dog calls bark many here, it's calling this one, which causes a loop. This is the kind of stuff that can happen.
Turn to dynamic method selection. And in this case, if we do vd.barkmany, the dynamic type of the vd variable is verbose dog, so we'll call this method. That will in turn call bark, and this .bark we see does not exist, so we'll turn to our superclass and we'll call bark. So we'll get, as a dog I say, bark, bark, bark. Now finally, the rub. Someone at Oracle decides, I'm going to switch these two methods. I like the idea of bark being here instead, the actual sound, so they changed this around. Now we already said that there's no way that an outsider could ever know, but here, perhaps maybe, something interesting happens. I mean, something does.
I got a little ahead of myself. So this is this implementation here. This is this idea here. So first he was talking about this one here, and now he's talking about this one. So
it's our job to figure out what exactly. So if now I do vd.barkmany3, I want you to consider this class and think about what happens. And think really hard because I'm going to spoil it shortly. Okay. So in this case, we call vd.barkmany3. Its dynamic type is verbose dog. So this method executes. We get here and we say this.bark. Okay. What's the dynamic type of this? Well, it is verbose dog, so we'll try and call the bark method of verbose dog. It doesn't exist, so we go to the superclass. This bark method executes, and it goes this.barkmany1. What is the dynamic type of this? Well, the object in question is actually its runtime type is verbose dog, so we call the bark many method with 1 as an argument. This in turn calls the bark method, which calls the bark many method, which calls the bark method, which calls the bark many method, and we get caught in an infinite loop. So what just happened there is that by allowing inheritance, in particular implementation inheritance, we now have a way to peek inside of what was otherwise a beautifully encapsulated class. There was no way to get in here, but we just showed we could. And in fact, it had dire consequences. We didn't change anything about our code. Someone else changed something they thought was safe, and kapow. Now, this doesn't happen in a practical way super often, but it does. And I think that
it happens in weird ways. Now this one's very clear and obvious, but it can happen in very strange, sneaky ways. And people can easily step on each other's toes when this is part of the code base.
Philosophically, it's something that makes me nervous about implementation inheritance. It breaks encapsulation in just a really distasteful way. And there are benefits to implementation inheritance, but there are trade-offs because we run afoul of this terrible philosophical awfulness.
Right. And then the professor says philosophical awfulness, right? It's a philosophical issue. And this is what makes the computer science people and the computer engineering people very uncomfortable. Because they don't like dealing with this stuff. They want the concrete. Give me what you want. I'm gonna tell you what you want, what I want, and I'll tell you where to put it, where, when. Give me a like and subscribe. I'll talk to you soon.